Good morning, good afternoon, and good evening. My name is Håkan Silfvernagel, and today I'm going to be presenting how you can run machine learning on the edge. So that means how you can run machine learning either on a mobile phone, or it can be on your Raspberry Pi, or it can be on a microcontroller. So how you can run machine learning directly on your device. But before we start, I'm just gonna give you some background information about me. So my background is I have been working in human-machine interfaces for process automation and robotics. And my educational background is I have a master's degree in electrical engineering, and I also have a master's degree in behavior science. I'm interested in artificial intelligence and Internet of Things, so I've taken some classes at MIT. I'm also involved in the local user group community here in Oslo. So I'm part of the Oslo AI meetup, and I'm also part of the Norwegian.net user group. And I'm also a Microsoft MVP in AI. But that's enough about me. Now, before we start talking about TensorFlow, I think it's quite important that we're all on the same page. So I'm going to give you a quick introduction to machine learning. So you might think that machine learning has to be something really new because it's such a hot topic today. But the matter of fact is that machine learning actually dates back all the way back to the 1950s. So there was a guy called Arthur Samuel. He said that machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. And you can also say that machine learning is a pattern recognition in historical data. So some of the applications of machine learning is prediction. So one classical example is if you're going to buy a house and you have data for previous house purchases, then you can see that you can predict how much will this house cost depending on the location of the house and how many rooms it has and when it was built and so on. You can also think about the recommendation system. So when you purchase something in a web shop, then you probably are likely to get some recommendations of other items that you would be interested in. Or you can think about clustering. So say that you have a large group of customers and you want to customize the advertisements to each user group. Then you can cluster people that have similar interest into a cluster, and you can customize the information to that cluster. Or you can do image recognition or text recognition or speech recognition. So one way that you can do machine learning is called supervised learning. So with supervised learning, what we have is we have access to historical input data and also historical output data. And based on that, you can build a machine learning model. And then you can train up this model so that it can take new data that it hasn't seen. So it can take real-time data, and then you can get a new prediction by using this machine learning model that you've trained. So you can think, why is it so that machine learning is such a hot topic today? Well, there's a number of enabling technologies that has made that possible. And one of them is that we have access to real-time, access to sensors that can give us real-time data. And we have also access to big data solutions, so we can do transformation in the cloud. And we also have machine learning algorithms that we can run. And for us as developers, we can make use of these in our own applications through the use of APIs. And I would also just like to describe some of the common languages that you can use in order to do machine learning. Now, I should also say that you can actually do machine learning in any language, but you don't really want to start out from scratch. Instead, you want to use a language which is mature and has a lot of libraries that can help you when you want to develop your machine learning model. And there are two main languages. One is Python and the other one is R. And from a historical point of view, Python has been more targeted towards people with a computer science background, whereas R has been more for people from academia with a statistical background. So now when we know a little bit more about what machine learning is, we're going to go talk a little bit more about TensorFlow. So TensorFlow is an open source library that was developed by the Google Brain team. And what is special with it is that it's expressed its algorithms using something called tensor operations. And a benefit, I'm going to be describing what the tensor is quite soon here. And one benefit with using TensorFlow is that it supports distributed computing. And that is a big advantage if you're going to do neural networks or deep learning. So what is a tensor? So you can differentiate between either a scalar, which is a real-time number, or a vector, which is a collection of numbers, or a matrix, which is like a two-dimensional collection. And then a tensor is just a container where you can store either a scalar or vectors or matrices. So if you're going to use TensorFlow, what you can do in Python is that you import TensorFlow, and then you start up a new session, and then you define a constant, which we call a with a value of 10, and then we define a new constant, which is b with a value of 32, and then we can make an addition, and then we can just print out the result on the console. But then what is TensorFlow Lite? So TensorFlow Lite is an open source deep learning framework so that you can deploy machine learning models both on mobiles or on IoT devices. So we're going to have a look a little bit further on here on how you can deploy an image classification model onto Raspberry Pi, and also a model for object detection on the Raspberry Pi. So TensorFlow Lite consists of two main components. One of them is called the TensorFlow Lite interpreter. So with this, you can run optimized models on different types of hardware. It can either be on your mobile or embedded Linux or on microcontrollers. And the other component is the TensorFlow Lite converter. So the converter converts TensorFlow models into a much more efficient form that you can use by this interpreter. And these are optimized in order to improve both the binary size and also the performance. So why would we want to use TensorFlow Lite? So there are also a number of reasons here. One of them has to do with latency. So since everything is taking place on the device, you don't have to have any round trip between the client and the server. And that's also a benefit in terms of privacy. So you have all your user data is local, so that is more secure than if you would need to transmit the data between the client and the server. And also in terms of connectivity, you don't need to have an internet connection. That's not required. And in fact, on many of these small embedded systems, you don't have enough power so that you can power up a radio transmitter. And also, you also have an API for multiple set of languages. So you can do this either in Java, in Swift, in Objective-C, C++, or Python. And another advantage is that you have pre-trained models for common machine learning tasks. And these models, either you can take them as they are right out of the box, or you can also customize these models. So the way that you do this, you pick a new model, or you can retrain an existing model. And then you can convert a TensorFlow model into this special format that with this TensorFlow Lite converter. And then you can take this compressed model and you can load it into a mobile or embedded device. And then you can also do optimization on that model. So these are some of the out-of-the-box models that you can use either for image classification that I will show you, and object detection that I will also show you, but you can also have text classification or natural language question answering or style transfer, or many other application areas. So now we're going to have a look at image classification. So basically what you do with image classification is that you will train a model. You will have a model that will be fed with images that has associated labels, which tells the model what is actually on this image. And then the model will learn, so then it will be able to predict what is on a new image because it can see that it belongs to a special class, and that class has a label associated. So there are some models that we can use out of the box. So one of them is called MobileNet. So the MobileNet model is trained on something called the ImageNet dataset, where it can recognize 1,000 different types of objects. And this is an example from a Coursera course where you can have a look at the code and everything on this link below. So the first thing that we need to do is we need to download a pre-trained model with our labels. So we can do this on a Raspberry Pi. We can just download a zip file where we both have the model and we also have the labels, which is a text file. And then we can unzip this to a directory. And then after that, we can run our classifier just by pointing it to an image. So we run this in Python. So we have a Python class called classify where everything, all the machine learning is taking place. And then we give it an input, an image. So in this case, it's a dog.jpg file. And then we also need to give it a path to our machine learning model and also a path to where we have the label file, which is this text file with labels. So when you do machine learning, then we call that inference. So the inference consists of 4 steps, which are similar. So one of them, the first step is to initialize this interpreter. And the way that we do this is in our code. First, we load our interpreter from the TensorFlow Lite library. Then after that, we will load our TensorFlow Lite model, and also we will allocate the tensors in the interpreter. And then we will get the input and the output tensors. So then we are ready to move on to the next step here. So in the next step, we need to prepare our image so that it has the right size so that we can use TensorFlow on our image. So the first thing that we do is we read our image and we convert it to RGB, and then we get it into the correct shape, and we do some image pre-processing that is needed by TensorFlow, and then we add a dimension here where we will have our classification of what the image actually is. And then in the third step, we do our actual inference. So we perform our inference by calling interpreter set tensor, and then with this input details that we just defined here. And then we can invoke the interpreter by interpreter invoke. And then finally, we need to obtain our result. And we also need to map our results so that we can see which label is it that it has identified. So we get the predictions from the interpreter, and then we get the indices of the top K results. So in this case, we get the 3 most probable results, and then we print this out on the console. So let us switch over to our Raspberry Pi and do some image classification. So now I'm on the Raspberry Pi, and then I'm running this command here. So in the command, it's a Python file called classify, where we have as an input, we have a file name, and then we have the path to our model and also the label path. And then we will test 2 different files. So first we have a file here, which is a file of a dog. And then we also have a file over here, which is a file of an image of a tiger. So let us try first here with the dog. So if we run this, we can see that it's predicting that this image contains a Labrador Retriever with 27%, a Golden Retriever with 13%, or a Kovac with 12%. So we can also try it with the tiger. So now with the tiger, it says that it is a tiger with 96%, and it's something called a tiger cat with 4%, and then it says toilet tissue with less than 0% here. So that's an example here of what you can do, how you can do image classification by using a pre-trained model. So let us go back here to the presentation. So then in our second example, we're going to have a look at object detection. So with object detection, we will use a pre-optimized mobile net SSD model, which is trained on something called the COCO dataset. So the COCO dataset has been trained on 80 different object categories. And we will also have a label file so that we can map the output of the model to a label. And this is also an example, so you can see the code here from this GitHub URL. And you can also download the TF Lite model and the label file from the URL that you can see here on this slide. So when we do inference here with object detection, we follow the same step as we did for the image classification. So first we initialize the interpreter, we prepare the image input, and we perform the inference, and then we obtain and map the results. So in the first step, just as previous, we load the interpreter from the TF Lite library, and then we load the TF Lite model, and then we allocate the tensors, and we get the input and the output tensors. Then we need to prepare the image input so that it's in the right size. So similar to here, what we need to do here is we need to be able to get the an object from the camera on the Raspberry Pi. So we define a class here called video stream, where we set up a resolution and we set up a frame rate, and then we want to read the first frame from this stream that we get from the web camera. And then we define a start method. So in the start method, we're actually starting up a thread that will read frames from the video stream continuously. And then we start an indefinite loop here that will run all the way until we say stop. So what we'll do, it will read each frame, and then it will make it available for us so that we can use it in our application here. So then in our program, we can initialize an instance of our video stream, and we set the resolution and the frame rate, and we call the start method of the video stream. And then we can grab the frame from the video stream by calling videostream.read. And then what we do after that is we resize these frames to the expected shape and the expected size so that we can then use the TensorFlow Lite model. So then we need to do the inference. So we call the set tensor just like we did in our previous example, and we just do interpreter invoke in order to do the inference. And then the final thing that we need to do is we need to obtain and map the results. So what we will get from this object detection is we will both get a box where it has detected an object. So it's a bounding box with coordinates of this object that it has detected. And we will also have a class, which is the index of this class, what it thinks that it is. And we will also have a score. So the score is the probability or the confidence level that it has. And and then when we do this, we will just loop over this and we will print it out onto the screen here. So we will have rectangles with the label name and also probability of the confidence level. So now we will switch over here to our Raspberry Pi. Let me switch over, and then I'm going to start up the object detection like this. So it's a Python program here that we just saw, and we just need to define where is our model located, which directory our model is located in. So we start this up. So, and then I'm gonna transfer myself over to the Raspberry Pi, this, and then I'm gonna hold an object up to Raspberry Pi, and then you can see first of all that it has detected me as a person, and then let's see, it says an apple with 52%, and then we can take another object, take this object, and it detects that this is a bottle with 55%. And then we can take this, and then it says that this is a remote control with 53% or something. So let us go back here to the presentation. So now we've done some basic examples here, both of image classification and object detection. So the question is, how can this be used in the real world? So let me give you an example here of how this has been used in a more real world scenario. So one example that I would like to present to you is called Neuro. So in Tanzania, there is a problem for the farmers in Tanzania that they are very dependent on the cassava plant. So the cassava plant will provide food for over 500 million Africans every day. So they know that if all other crops will fail, they can rely on this cassava plant. So then if the cassava plant gets a disease, it's a real catastrophe. So the problem is here, how can you identify a disease on the cassava plant so that you can do some measures against it? So then there were some researchers from Pennsylvania State University that worked together with some researchers from the International Institute of Tropical Agriculture. So they developed an app called Neuro. So if you look at this picture on the top here, you can see some farmers. They're looking at the cassava plant, on the leaves of the plant, and then they can just use their mobile and they will run a TensorFlow Lite model on their mobile that has been trained to detect if the cassava plant has a disease or not. And if you look at the last picture, you can see that it also does this detection, and it can detect if the plant has this disease. So it's been trained on 5,000 high quality images that it's collected, and it's also used the mobile net that we were trying out a little bit earlier. And if you want to know more about this project, I recommend you to look at the short movie, which is on the YouTube link on the slide. So another example here is actually that you can run also TensorFlow Lite on a microcontroller. So there's something called a SparkFun Edge development board. So this was premiered on the TensorFlow on the Google I/O conference last year. So what it is, it has 384K of RAM and 1 megabit flash. So it has a low single digit milliwatt power usage. So it can run for a very long time. So what you can use it, you can have speech detection. So with speech detection, it doesn't require, the speech detection models are not as big as the image classification models, for example. So in this example, you can run a model which is just using 20K model. So you can run this If you run it, it will use less than 100K RAM and 80K flash. Another example is called the Coral Dev Board. So this is a single board computer. It has 1 gig RAM and 8 gig flash. So it's using something called the Edge TPU, which is a tensor processing unit, which is a specialized processing unit for deep learning and machine learning. And it's called an AI ASIC, an AI accelerator application specific integrated circuit. And by using this, you can run TensorFlow Lite models on it. So finally, I have some references. So the first reference is for the TensorFlow Lite official documentation. And I also have some references to the Google I/O conference that I was talking about and to the TensorFlow Dev Summit from last year. There is also a free YouTube course if you're interested into machine learning. So it's called Zero to Hero. So you can start with basically nothing. And I'm also giving you some links to some courses on Coursera, Introduction to TensorFlow, and also this course called Device-Based Models, where we took this image classification example. And I'm also giving you a link to a GitHub directory where you can see more about this object detection class. So with that said, I would like to thank all of you so much for your time. And if you want to know more, or if you have any comments or any questions, you can reach me either on Twitter, where I'm called Agreeablis, or you can reach me on my email address that you can see here on this slide. So with that, I would like to wish you a very good conference, and thank you so much for tuning in.